In this next module, we're going to do a practical example. I'm going to walk you through how to interpret linear regression results in a medical paper. We're going to go back to this vitamin D and cognitive function study that I mentioned in the teaser, and that was also the basis of all the hypothetical data I've used this week. Now I'm going to show you the results from the actual study. So the headline that came out in 2009, this was widely covered in the news media, was things like Brighten the Twilight Years, Sunshine Vitamin boosts brain function in the elderly. And the articles made the point that this is some of the strongest evidence yet of a link between vitamin D levels and cognitive function. So remember what this study was. This was a large cross-sectional study of middle-aged and older men in Europe. They measured their vitamin D levels at one time point. They also had them take some various cognitive tests to measure their cognitive function. There were actually a number of cognitive tests they took. I've been focusing so far on the DSST score, but I'll show you some others in a minute. And they found an association between those things. We're going to kind of walk through that in a minute. But this study had a number of, it was all linear regressions, so lots of linear regressions were run, and a number of the tables involved the output from linear regression. So we're going to walk through it. We're going to evaluate how strong this evidence is. So here's table 2 from that paper. It's rather large and cumbersome, but in a minute I'm going to go through it bit by bit and kind of zoom in here. So this table was trying to get at what are some of the potential confounders that might confound the relationship between vitamin D level and cognitive function. So what it's showing you here is each of the columns represents a different outcome variable. So the first column is showing you the results of a bunch of linear regressions where the outcome variable was a cognitive test called the ROCF copy score. There were 4 cognitive tests administered here, so we get results for the ROCF copy score, the ROCF recall score, the CTRM score, and also the DSST score, the one I've been talking the most about. And we also get a series of models which use vitamin D as the outcome variable. Because remember, to be a confounder, you have to be related both to the predictor variable and to the outcome variable. So we're trying to assess which of these third variables is related to both cognitive function and vitamin D, and thus might be confounding that relationship. Now I'm going to walk you through these are all beta coefficients that you're seeing here. I'm going to walk you through what these beta coefficients mean and how to interpret them. Let's start with age. Age is a continuous predictor. It's measured in units of years, and for continuous predictors you need to know what the units of measurement are, and they nicely put that for you in the table here, so we have it. There's a lot of data here, so I'm just going to go over a couple of these. So first of all, if you kind of scroll across all the different cognitive tests, you'll notice that there's a little star beside each of those estimates. As your age goes up, your cognitive function goes down on all of those tests, and it is statistically significant. That's not surprising. Interestingly, I'll focus for the moment on the vitamin D. The vitamin D was not that strongly related to age in this study. So the coefficient here, the beta coefficient, is negative 0.0135. So that does mean that as your age goes up, the outcome here is vitamin D. So as your age goes up, your vitamin D level goes down. For every 1 year increase in age, we are decreasing our vitamin D levels by an average of 0.0135. So it's not a big effect, and it's not statistically significant. Let's look at the beta coefficient for DSST score. So for DSST score, the beta coefficient is negative 0.415. That says that for every 1 year increase in age, your DSST score is going down by 0.415 of a point, almost a half a point. So that's a pretty big effect. It is statistically significant. These models right here have not been adjusted for anything. The rest of the models that I'm going to show you are adjusted only for age and nothing else. Now I want to show you an example of a categorical predictor. So they also measured depression on these men. They measured depression on the BDI, the Beck Depression Inventory. They classified men into normal, meaning no depression, mild to borderline depression, and moderate to extreme depression. They used those 3 groups then in linear regression, and again, these models are all adjusted for age but nothing else. Let's choose the CTRM score here just for fun to look at something different. So the way that you would interpret these coefficients, everything is compared to the reference group. So the reference group is the normal. Then we see that if you have mild to borderline depression compared with having no depression, with being normal, you go down in your CTRM score by 0.849, and that is statistically significant. If you're in the moderate to extreme, the higher depression group, you go down on average by 1.4 points if you're in moderate to extreme depression compared with if you're normal. And that also is statistically significant. Interestingly, let's look at the vitamin D, where vitamin D is the outcome, those models. So if you if you're in the mild to borderline depression group, your vitamin D levels go down 9.641 nanomoles per liter. So that's a pretty big drop in vitamin D with depression. And if you're in the highest depression group compared with normal, your vitamin D levels are 13.93 nanomoles per liter lower. So those are some big drops in vitamin D. So interestingly, if you're depressed, you're likely to have lower levels of vitamin D. You are also likely to have lower levels of cognitive score. So this is definitely a potential confounder here. Body mass index, a measure of how big you are, your size, is also a continuous predictor. Let's look at DSST score. So as your body mass index goes up, actually your cognitive function goes down. Every 1 unit increase in BMI, BMI is measured in kilograms per meter squared, correlated to a 0.115 decrease in your DSST score. So not a huge effect, but it is statistically significant. For vitamin D was also related to BMI. So as your BMI goes up, for every 1 unit increase in your BMI, your vitamin D levels go down 0.811 nanomoles per liter on average, and that is statistically significant. So again, BMI could also be a confounder. As your BMI goes up, your vitamin D levels go down, and so does your cognitive function. There's another categorical variable, physical activity. So this is the low, medium, and high exercise groups. And let's look at CTRM score. So for CTRM score, if you are in the middle exercise group, you are about 1.283 points higher on your CTRM score than the low exercise group, and that was significant. And the highest exercise group was also about a little over a point higher than the low exercise group in CTRM score, also statistically significant. So more exercise seems to be correlated with somewhat bigger cognitive function. Interestingly, vitamin D also correlated with exercise. So if you were in the middle exercise group, you were 5.148 higher in your nanomoles per liter in your vitamin D compared with the normal group. The high exercise group was on average 7.072 nanomoles per liter higher in vitamin D. So if you're exercising a lot, you tend to be outside more, you have higher vitamin D levels. Again, could be a confounder, right? More physical activity, better cognitive function, and bigger vitamin D. How about smoking? Okay, well, not surprisingly, for smoking is a binary variable, so it's easy to interpret. Vitamin D goes down with more smoking. So if you're a smoker compared with a non-smoker, the reference group here is non-smoker. Smokers are on average 10.95 nanomoles per liter lower in their vitamin D levels than non-smokers. And also notice that across all of the cognitive scores, your cognitive score goes down if you smoke. So another potential confounder. How about alcohol drinking? Well, interestingly, alcohol drinking is correlated with slightly higher cognitive function, at least on the CTRM score and the DSST score. So if you were a drinker, alcohol was coded as a binary variable, so drinking at least 1 drink a day versus less than that was correlated with a slightly higher DSST score, 2.159 points higher, and that was statistically significant. So for some reason, drinkers tend to have slightly higher cognitive function. It might not be due to the drinking, but those tend to go together. Similarly, drinkers also tend to have better vitamin D levels. So if you're a drinker versus non-drinker, your vitamin D level was 8.521 higher on average. So again, that one could be a confounder too. So there's many potential confounders in this data set that need to be accounted for. Now I'm going to jump to the heart of this study, the table that actually shows you the relationship between vitamin D and cognitive function, which was what this study was trying to get at. Remember, this is a cross-sectional study. I'm going to kind of walk you through this table. Remember, the headlines said that this was the strongest evidence yet of a link between vitamin D level and cognitive function. So let's see how strong that evidence is. So first of all, if you look at the first row here, I'm highlighting the CTRM test score and the DSST score because those are the two that had a significant relationship with vitamin D in this data set. If you just adjust for age, which is what that first row is, this is the result of linear regression with the cognitive score as the outcome and vitamin D as the predictor, adjusted for age only in that first row. So when you just adjust for age, there is a statistically significant relationship between vitamin D levels in both CTRM score and DSST score. It's not huge, but there's a relationship there. So for example, the 0.318 beta coefficient, the way we would interpret that as is for every 10 nanomoles per liter increase in your vitamin D levels, your DSST score goes up by about 1/3 of a point. Just for comparison, remember that I made some mock data sets. The low, in those mock data sets, the very low relationship one, I had a beta coefficient of 0.5. So this 0.318 represents an even smaller relationship than the lowest of those data sets, the hypothetical data sets. I had a hypothetical data set with 0.5, another one with 1.0, and another with 1.5. So if you go back to those sides, that very weak relationship was 0.5, so 0.318 is even lower than that, but it is significant. The next row represents after you adjust for a lot of things. So if you look at the footnote, after you adjust for age, education, depression, body mass index, physical activity, physical performance, smoking, alcohol, center, and season, all these potential confounders identified in table 2, what happens to the estimates? Well, look at CTRM test score. Once you adjust for these confounders, it disappears completely. There's no relationship now between vitamin D and CTRM test score. That beta coefficient is essentially 0. For DSST score, it does hang on to a small relationship, but notice that the beta coefficient has been attenuated greatly. When we adjust for these confounders, it decreases by more than 50%. And now that beta coefficient is pretty small. It's a 0.15 point increase in DSST score for every 10 nanomoles per liter in vitamin D. That's 1/10 of the hypothetical data set I was showing you with the slope of 1.5, which was kind of a moderate relationship. So it's 1/10 of that relationship. So it's really, really small. It does hold on to statistical significance. However, it's a small relationship, and you have to remember that it really gets attenuated when you adjust for confounding here. There's probably a lot of things that we haven't adjusted for here, and we haven't adjusted for them perfectly. So a lot of that 0.15 is almost certainly also due to confounding. It's just that we haven't completely adjusted for it. So this is not this is not what I would call, rocket evidence, great evidence that that there's a huge link here. This is also a cross-sectional study, so we don't know the direction of the causality, if there is any causality here. It could be that if you have better cognitive function, you go outside more, you take better care of yourself, and that's why your vitamin D is just a little bit higher. So the direction of the effect, of course, is unknown here. Just for practice, let's also look at the vitamin D categories. So besides looking at vitamin D as a continuous predictor, they also broke into potentially clinically useful categories, similar to what I did in an earlier module. They made 4 categories: sufficient, suboptimum, insufficient, and deficient. And the reference group is obviously the sufficient. So for example, the deficient group, the beta coefficient's -1.4. So that would say that if you're deficient, that's a very low level of vitamin D compared with normal above 75, or what they are calling sufficient. You are on average 1.4 points lower in your DSST score. That does remain statistically significant after adjusting for all these confounders. But again, it's still a fairly small effect. So I wouldn't call this, huge evidence of a great, strong, big link between vitamin D and cognitive function.